I'm going to discuss about the topic called differential calculus. Here I have mentioned a square. So this square having the edges of x and mentioned the area as y. So the area of this square may be calculated as y is equal to x square. Y is equal to x square. The differential of this y may be taken as dy equal to 2x. This equation is not familiar to everyone. It will be familiar to everyone. So this equation derived with a simple methods called how I brought this equation from the equation as y equal to x square. So I am taking the differential dy. From the square, we have some area to be calculated, and we mentioned the y equal to x square from this equation. So next the diagram implies how it came, while dy equal to x square. So here I am writing the differential of x implies. So here we have mentioned dy equal to 2x. I will show you how this equation comes from. The differential of x from the both sides shown upon the square. I have shown y equal to x square. So the differential of y will be 2x. This equation is elaborately explained in this diagram. I will show you how it does. So this side I have mentioned as x, and the above dotted lines are explained with denoted as dy. Same as from these edges as x and respectively dx. So after multiplying this two terms dx, x dx, and the bottom side plus x dx. This equation is the elaboration of dy term. As it is mentioned here earlier, I have elaborated just doing the dotted lines and mentioned the dx. So after summing these two things, 2x dx, which implies the dy. And the furthermore steps includes while bringing the dx from the right hand side to the left hand side of dy. Dy by dx equal to 2x. This is the final formula for calculating a differential calculus for dy. So from the left hand side, I have brought the equations as dy by dx equal to 2x. I am explaining the topic functions from differential calculus. I have mentioned the here x. I have given x as an input. This x will be gone through these functions. And it would produce the desired output that will be unique. The one input that contains one output as well. So here I am mentioning these examples how it works. Consider substituting the value of x as 1. This equation will become as I mentioned earlier, this input value of x will contains the exact unique value given as output. Here all I mentioned the few sums related to functions in differential calculus. So I am explaining the first term. Before that, I have to draw a line which contains minus infinity to plus infinity. This interval of range. So first of all, I am substituting the value of x as 1. The answer will be 3. So the value will be taken between these two ranges from minus infinity to plus infinity. So the end domain will be this curly braces. The domain of the above mentioned problem will be from infinity till minus infinity to till infinity. So I will be explaining why we are mentioning as curly braces, circular braces. Coming to this problem, x by modulus x. For this problem, the ranges from as it is I am drawing the ranges as minus infinity to plus infinity. As we are substituting x with the value of 0, this whole term becomes infinity or unidentified term. So I am making it an example. X divided by modulus x with substituting 0 value. 0 by 0 will be unidentified term. So we are negating the 0x from these ranges. Minus infinity to plus infinity, we are eliminating 0 only. So we are mentioning this 0 term here. From minus infinity till 0, we are including all the terms except 0. From above 0 to infinity, we are including all the terms. So except 0, we are not including in this problems. I will show you how it works. From minus infinity to 0, we are not including this infinity. So we are opening with this circular brackets. Minus infinity till 0. 0 are not included in this. Substituting the value of x. So comma 0 and representing with this circular brackets. These next interval will be union with this previous interval. As well, 0 are not included, so I am mentioning the open bracket, circular bracket, and the last term infinity, that also will be not included. That will be represented in this opening with closing circular brackets. Coming to this term, root of x. We substituting the value of 1 to the root of x. X as 1. Next, f of x equal to root of x. The term contains root of x. So it will be somewhere representing as minus infinity till infinity. The numbers from these ranges will be included in root of substituting with represented to x value, root of x. In case of substituting with 1, root of x will be taken as root of 1, and that will be 1 itself. So the domain range will be from infinity to the infinity. The next problem will be not as complex compared to before one. So here you can see this x at the denominator. So there will be a possibility of becoming undefined term. So I am mentioning as before minus infinity till infinity. So the value becoming 0 at the domain denominator. Only this 0 itself. So I am not mentioning minus infinity, 0 and infinity as well. So the interval becomes minus infinity. This brackets represents not including minus infinity term, 0. These two are represented within this opening and closing brackets. And union with this interval, second interval from 0 to infinity. I am not including 0 and infinity also. So domain will be minus infinity to 0, not included these two terms as per the infinity term. The next function will be, so here I mentioned x plus 3, denominator 4 minus the term means term with the root. So I separated the term with the root x square minus 9. So I have the function represents x plus 3 by 4 minus root x square minus 9. I am separating these root terms. And the next function represents x plus y 4 by 4 minus root of x minus 9. I am separating this term along the root term x square minus 9 and equating this term with the 0. Calculating the value of x will be taken as x equal to, bring the 9 to that side, x square equal to 9. The x will be plus or minus 3. The term 3 plus or minus 3, these both terms will not be included in this interval between minus infinity to infinity. I will tell you why does it not be included in this interval. So this minus 3, substituting in this value x plus 3 by 4 minus root of x, this value. I'll show you how it will be. We're taking the x value as minus 3, substituting in this term minus 3 plus 3, 4 of minus root of minus 3 square minus 9. The numerator will become 0. Inside the root term, minus 3, the whole square will be 9 minus 9. Inside the root, the plus 9 minus 9 gets cancelled and the root contains 0. Both numerator and denominator is 0. So the end solution will be undefined. So we are not taking minus 3 plus 3 in the interval of infinity. Next, the term 5 will be not included in this solution. In this term, I will show you. Consider we take the term of x 5, substituting in that 5 the whole square will be 25 minus 9. So calculating the root term alone, it will be given somewhat root 16. The root term alone will be 16, root 16. The end value root 16 will be E4. The 4 minus 4 get cancelled. The denominator will be 0. So the domain it ranges from, we are not including minus infinity, minus 5 not including step. These two terms are not including the range. Minus infinity to minus 5 we are not including. Union with the term from minus 5 to minus 3. We are not including any elements between these two ranges. And the 3 till infinity, we are not including this term also. N domain it will be produced as minus 5, we are not including, so I mentioned this in the open brackets. Till minus 3, we are not including. These two intervals will be unique. From 0 to 3, we are including 0 and 3 as well. So, we are including as 0 mentioned in this square brackets. Till the range 3, we are including 3. So, I have mentioned the 3 in square brackets. Above 3 until infinity, we are not including that interval. So, I have mentioned union with 3, infinity. So, the n domain it will be these 4 intervals union together. The second topic I am going on with this matrix and determinants. So, these sum will be the familiar here. Upon the second topic called matrix and determinants. The questions left hand side we are A into B the whole inverse. I am going on with this second topic matrix and determinants. Here I mentioned left hand side the A B the whole inverse, and we have to bring the equation from the right hand side as B inverse into A inverse. So we have multiplied A into B. The matrix multiplication will be simple as we are taking this first row multiplied with this first column. As 0 into minus 2 will be 0. Minus 3 with 0 will be 0. Calculating the first term will be 0. Actually, taking the second row, calculating with this first element, first column, we have come upon these solutions as mentioned 0, 3, minus 2 and minus 7. So, I am taking the left hand side from the above equations as A into B the whole inverse. The power will be as minus 1. So here I will mention the formula how to calculate the one term with which the power of minus inverse. So here as the D matrix, and the D matrix will be inverse to be calculated as first we are mentioning the one in the numerator and the corresponding terms, diagonal terms A into D, and we are have to difference with these terms as C into B. I think I am going to explain about the matrix and determinants. Here, having a set of equations, so I am taking about the LHS and comparing it with this RHS. The end result will be equal, compared with equal. Okay. So I am mentioning A into B. So A into B will be calculated as we have to separate two terms A and B as 0, 1, minus 3, 4. Now the matrix multiplications, the first row will be multiplied with these first columns. 0 into 2, 0. Minus 3 into 0, 0. This first row will be multiplied with this second column. So I will show this term will be this second solution. 0 into minus 3 will be 0. Minus 3 into minus 4 will be plus 12. 1 into minus 2. This second row is multiplied with this first column. Minus 1, minus 2, minus 2. Plus 4 with 0, 0. Minus 1, sorry, plus 1, minus 3 as minus 3. 4 minus 4 as minus 16. The end value will be the A into B calculated as 0, 12, minus 2, minus 19. Before calculating the inverse of A into B, I will explain the formulas initiating this. So here we have a D matrix. The D matrix will be inversed using the formula. 1 I will taken as numerator with multiplied as A into D diagonally. We are multiplying A into D, finding the difference with B multiplied with C. And we are taking interchanging A term with D to the position of A. And we are including the negative terms of C and D. This formula will be applied on calculating the negative of A into B. As mentioned in that formula, giving the numerator as 1 and multiplying the diagonal elements as minus 19 with 0 as 0, and the subtraction of the second term will be minus 2 with the 12. Minus 2 into 12, it will be minus 24. So the negative symbol is mentioned in the formula earlier. So the minus into minus, it will be plus. The negative formula, for inverse formula, the diagonal elements get interchanged with the positions minus 19 and 0. The second diagonal will be interchanged with the only the sign elements, as from will be before it represent minus 2. So we are giving 2, and these plus 12 will become negative 12. Then calculated as 1 by 24 as numerator and denominator, and these terms as it is. A into B, the whole power minus 1, calculated in this thing. We are brought up into the LHS. Myself, Ajay Emirates, and I am pursuing 4th year BTech IT from SNS College of Technology. Today I have taken the topic related on matrix and determinants and concept involved in differential calculus. The differential calculus, I have mentioned how it works as the emerging difference between square as well. I have also mentioned it in the cube format. The differential calculus will be used in day-to-day life from calculating 0.1 seconds difference, basically related to closest to zeros. I have also done with this matrix calculations, simple matrix multiplications that can be implemented with. Also teaches with the inverse of a term. The formulas I have also mentioned how it will be calculated by interchanging diagonals as well as the sign get changed. That's all from today's class. Thank you.